Hi everyone and welcome back to the second video on section 8.2. So we're going to look at the problems that are associated with finding the complementary solution. So looking at letter A, we have y double prime minus 4y prime plus 20y is 0. Okay, so we make the substitution y equals e to the rx, so therefore y prime is r e to the rx, and y double prime is r squared e to the rx. X. So that's r squared e to the rx minus 4 r e to the rx plus 20 e to the rx is equal to 0. Each term has an e to the rx in it. Factor that out. You get r squared minus 4r plus 20 is equal to 0. Okay. Now, you can see right here that the auxiliary polynomial comes directly from the initial differential equation, where the coefficient on r squared is the same as the coefficient on y double prime. The coefficient on r is the same as the coefficient on y prime, and the r to the 0 term is the same as the coefficient on y without a derivative. Okay, so henceforth and forevermore, we can jump straight to from the initial example to what our auxiliary polynomial is without having to do this intermediate step. So now that we know the auxiliary polynomial is r squared minus 4r plus 20, we look to see how that factors. Okay, well, it doesn't look like it factors. So what we should do is look at the quadratic formula. So r equals negative b, so that's 4, plus or minus the square root of b squared. B squared is 16, minus 4 times 1 times 20, all over 2 times 1, so that's 2. So this is 16 minus 80, which is a negative 64. So that's r equals 4 plus or minus the square root of negative 64 is 8i all over 2. So that's what? Factor a 2 out of the top, you're left with 2 plus or minus 4i. That 2 will cancel with the 2 in the denominator. So those are our roots to the auxiliary polynomial. So what are we working with? We're working with complex solutions. Now, we just got done with an example on how to work with complex solutions. This is the real part, so this is the imaginary part. So in our solution, we'll have C1 times e raised to the real part, so it's e to the 2x, cosine the imaginary part, 4x, plus c2 e to the 2x sine 4x. So our second order differential equation has two parameters. Okay, so that's consistent with what we were taught there at the beginning of the course. And there's our two linearly independent or independent pieces. And it's as easy as that. Now, with the second example, we have y double prime minus 6y, 16y is equal to 0. So what is our auxiliary polynomial for that? So auxiliary polynomial is r squared minus 16 equals 0. So that is r minus 4 times r plus 4. So that's r equals negative 4 and 4. And now we have distinct real roots. So looking back in our previous video with distinct real roots, you get e to the first root, negative 4x, and e to the other root, 4x. Again, second order differential equation, two arbitrary constants. What about number 3? Y double prime plus 16y. So, our auxiliary polynomial is r squared plus 16. So, what are our solutions? R squared equals negative 16, so that's r equals plus or minus 4i. So in this case, it's 0 plus or minus 4i. That's the real part, that's the imaginary part. So when writing our general solution, it would be c1 e to the, and I'm being very careful in this first step, e to the 0x cosine 4x plus c2 e to the 0x sine 4x. But e to the 0x is just 1. So this is really y equals c1 cosine 4x plus c2 sine